Hello everyone, welcome to Technologies Discussion channel. Today, I'd like to continue the discussion on filter design. This video is actually requested by one of you guys. Someone actually asked me, how can we actually determine the width and also the length of a microstrip line given the characteristics impedance and also the length of the microstrip line? For example, quarter wavelength or half wavelength design. How can we actually make use of these two in order to determine the width and also the length of a microstrip line? This will be the Part 21 series discussion on filter design. I have put the playlist under the description. So if you're keen to know more about filter design, take a look on the playlist in order to know more about filter design. This is my email. If you have any question regards on today's discussion, please drop me an email. Before I continue, again, I'd like to sincerely urge you guys to support this video by giving it a like. And also, please consider to subscribe if you feel all this information is relevant and helpful. Please also turn on your notification bell in order to receive more information from this channel. Once again, sincere thanks for your strong support. On the Part 18 series discussion, I have discussed how can we actually design a bandpass filter. I have arrived how can we actually reach all these admittance value and also the length of the microstrip line. But I guess this is something that I shot off at the Part 18 series. How can we actually translate the schematic into this microstrip line? So this video, I'm going to show it to you step by step and also formula. How can we actually convert all this schematic into microstrip line? There are various types of microstrip line. For example, for this microstrip line, it actually implement on a Roger board, which has a dielectric constant with a relative dielectric constant of 10.2 and also a thickness of 0.635 mm. And the center of operation, okay, for this bandpass filter will be at 2 GHz. So later on, I'm going to show it to you step by step. How can we actually transform all this schematic into microstrip line as indicated over here? Okay, let's start by discussing on the formula. Okay, so for this formula, there are actually two ways. One way is we actually have the characteristic impedance. How can we actually translate the characteristic impedance into the width? Another prospect is basically we have the width. How can we actually make use of the width, okay, to obtain the characteristic impedance? So for this particular case here, we actually has the dimension of the microstrip line, okay, which means that we actually has the physical dimension of the microstrip line. How can we actually make use of this information to transform them into finding what will be the characteristics impedance? So this will be the equation. Okay, so this equation are obtained from Professor David Poza. Okay, the particular book is a classical textbook which I have been studying for many, many years. So from this equation here, you can see that there are actually two different equations. So which one to use is basically depend on the ratio of the width over the depth of the microstrip line. Okay, so the width is basically the width of the microstrip line. Okay, the depth here means the depth of the microstrip line. Okay, so basically these two factors, okay, the ratio will allow us to choose either one of the formula. For example, okay, for this particular case, if the W over D ratio, okay, so-called they are less than 1, then I will use this equation. And if my calculation, the width over the depth, okay, of the microstrip line is more than 1, then I will apply this equation in order to find the characteristics impedance. Okay, so you probably see this here, okay, which is the effective dielectric constant. How to get this term, okay, the equation is mentioned here. So basically this page here, I actually know the dimension of the microstrip line. For example, I know my W, okay, what will be the width of the microstrip line. I know the thickness of my microstrip line, and also I know my dielectric of the microstrip line, then with all these characteristics, I actually can obtain my characteristic impedance by applying one of these equation. Okay, which one to use is basically on the ratio of the width over the depth of the microstrip line. So basically, this will be one of the way. Another way, okay, basically is I know my characteristic impedance. How can I actually make use of my characteristics impedance to find my width? Okay, so this is a reverse. Okay, earlier on is simply how to find my characteristic impedance given the width and the diameter. For this particular case, okay, I actually know my characteristic impedance. Okay, how can we actually transform them into my width and also how to transform that into my width? So over here, you can see that again, this will be a ratio. Okay, from this ratio here, you can see that there are actually mainly two forms here. Again, which one to use basically depend on the ratio of the width versus the depth of the microstrip line. I guess you have some idea how I actually can obtain this. So basically, if let's say the width over the depth of the microstrip line is less than 2, then I will apply this equation. And if my width over the depth of the microstrip line is greater than 2, then I will apply this equation. Okay, over here, you probably see that the A term and B term, okay, basically all the A term and B term, okay, is described by this equation over here. Let's quickly move into an example in order to understand better. Okay, for example, I need to design a microstrip line, okay, on a 0.5 mm. Okay, so basically this will be the D 0.5 mm substrate. Okay, so basically I know my dielectric constant will be 9.9. Okay, the characteristic impedance will be 50 ohm. Okay, I need to find the length of this in order to provide a phase delay of 270 degrees at 10 gigahertz. Okay, so I need also to compute the total loss on this line. Okay, assume that it's a copper conductor. Okay, so firstly, how can we actually find the width over the depth of the microstrip line? So you know that earlier on I have mentioned that this will be the two equation. Okay, but before we know the width and also the depth of the microstrip line, we do not exactly know which equation to apply. So we just choose this because this equation is so much easier. Okay, so if we do this and finally we need to fall back on this, I think the effort is huge. So therefore, for the first case here, typically I will advise you to choose this case. So let's assume, okay, the width, okay, and versus the depth of the microstrip line is less than 2. So I will use this equation to compute my width and also versus the depth here. Okay, so all these A term and B term, they are actually all here. So basically with this, I actually calculate my A term, okay, because over this equation, I just need my A term. So I can find that my A term is 2.142. Okay, so once I have this, I actually can find my W, okay, over the depth of the microstrip line, which is 0.9654. Okay, so from here, you can see that the equation that I try is actually correct. So basically, I can continue to work on. So this is what I mean. Okay, the condition is actually satisfied. Otherwise, if it's not satisfied, I probably need to use another equation. But for this particular example, the condition actually satisfied. Okay, because W over the depth of the microstrip line is less than 2. Okay, because the actual value will be 0.9654. Okay, which is less than 2. So once I got this here, I can actually also calculate the width. Okay, remember this is basically I just move my D, okay, which is the depth of the microstrip line over. So what I'm going to do is 0.9654 multiplied by 0.5. I actually obtain this number, which means that the width of a microstrip line for this 50 ohm, okay, they need to be at 0.483. Okay, so basically this will be the width of a microstrip line. Okay, I hope it is clear. Okay, but to be very frank, nowadays, I don't think anybody will calculate. Okay, so next, okay, I also going to show it to you. How can we actually get the length? We actually obtain the width So next, I'm going to show it to you how we can actually get the length of a microstrip line. Okay, so how can we get the length? Okay, the question actually requests to have a 270-degree phase shift. Okay, so basically this is the phase shift here to be 270-degree. They are actually equals to beta length. Okay, so this beta, okay, actually will be this equation here. Okay, so will be this equation here. So basically these two things I can find. So basically this part here I can find from this part, which is 6.665. And then this K naught, okay, which is 2 pi F over C. C is actually the speed of the light, which is 3 times 10 to the power 8 meter per second. So I actually successfully obtained these two numbers here. So this is the length of a microstrip line. Okay, so how to find the length of microstrip line? I know this is 270-degree. I just need to shift these two terms, which means that 270-degree divided by these two terms, okay, which is over here. But what I'm going to do over here is basically I transform this degree into radian. I transform this degree into a radian mode. So therefore, I know that the length of a microstrip line need to be at 8.72 mm in order to achieve 270 phase shift. So I have successfully calculated the width of the microstrip line, which is 0.483 mm. And I have also shown that the length need to be at 8.72 mm in order to have 270-degree phase shift. Okay, but like what I mentioned earlier on, frankly, okay, no one is going to do all this calculation because it's going to be very tedious. Okay, so therefore, you can actually use some resource from the internet to calculate the width and also the length, which I'm going to show it to you here step by step also. Okay, so for this case here, let's continue. Okay, so if you find this video, okay, interesting, please again, consider to like it and also subscribe to this channel. Okay, so first thing here, basically earlier on, I have obtained all the admittance. So the task for me to do is, I'm going to get the impedance. So what I need to do is basically 1 over admittance. For this case, it will be 1 over 0.02586. I actually obtained this number, which is 38.67 ohm. Okay, all these number, I just need to do 1 over. Okay, for example, over here, I just need to do 1 over 0.02787. I should be able to get 35.88. Same for this over here. So what I need to do is basically I do a 1 divided by 0.06937. I supposed to be able to obtain 14.42 ohm. So basically these are all the impedance. Early on, all these are all the admittance. So I just do 1 over to obtain all the impedance. So next, I'm ready to so-called obtain the W and the length of the microstrip line. How can I actually do about this? Okay, so this is actually what I have shown to you earlier on. I got all the impedance value, okay, and I have also know the length of microstrip line, which is a quarter wavelength, in order to achieve this bandpass filter. Okay, so for this particular filter design, okay, I am going to use my dielectric as 10.2, okay, with a thickness of 0.635 mm, and also this will be the center of frequency. How can we actually design this? Okay, so like what I mentioned, nowadays we are going to use a lot of resource online. Okay, so I actually have this resource online. So let me show this resource online first. Okay, so like what I mentioned earlier on, typically nowadays, no one will really do the calculation of the width of the length of microstrip line step by step. There are various forms of online so-called gadget that can actually help us to obtain this. So the one that I'm going to use will be the emtop.com. So basically what you need to do is you go to www.emtop.com, actually choose this M scale, which is for the microstrip line, what will be the width and the height of the microstrip line. Okay, so basically once you come into this web page, okay, I will put this link under the description. So basically you can click this link in order to come into this page here. Okay, so I will put this under the description, this link. Okay, so once you come into this web page here, you can see that this is basically the microstrip line calculator. So you need to enter these 3 parameters. Okay, for example, I have mentioned that the dielectric that we are going to use will be 10.2. So we just enter 10.2. Okay, so basically this will be the dielectric of the Roger board that we are going to use. Okay, the height, okay, basically for filter, let's say we are going to do this 0.635, which I have mentioned earlier on also. Okay, so basically you can choose, okay, either mm, also mils. Okay, but for this case here, I'm going to choose millimeter. The center of frequency will be at 2 gigahertz. So I'm done with this part. Okay, so if I slow down, okay, so next is basically, for this case here, I actually have the impedance. I'm going to calculate my width and length. So therefore, I'm going to enter these two parameters in order to obtain the width and length. Okay, so let's do the feeding line. Okay, so the feeding line is actually 50 ohm. Okay, so feeding line is 50 ohm. Okay, the length of a feeding line is not so crucial. Okay, so it can be any length, but for this case here, I need to enter the number before we can obtain the W and L. So let's say I enter them as a quarter wavelength, okay, which is lambda over 4. So lambda over 4, this value is supposed to be 90 degree. Okay, lambda over 4 supposed to be 90 degree. Let's say it's lambda over 2, which is half wavelength, then this will be 180 degree. So once I've done this, okay, I can actually obtain my W and L. So you need to just click this, synthesize it. Okay, so give it some time so they refresh it. Okay, then they have successfully calculated the W and L. Okay, since this feeding line, I only just concern about the width of the microstrip line, which is 0.59. And if we go back, okay, to the PowerPoint that I showed to you earlier on, okay, you can see that, okay, this width here, okay, is actually 0.59. So this will be the feeding line. Okay, 0.59 will be the feeding line. Okay, so next, I'm going to show to you how they actually obtain this width, okay, as 0.97 and also the length of this microstrip line at 14.03. Okay, basically they have this characteristics impedance 38.67. Okay, remember this number 38.67, and also the length is actually a quarter wavelength. Okay, so remember this 38.67. So again, we just need to switch into the microstrip line calculation here. Okay, so over here, we just need to change 38.67. Okay, and then we click this synthesize here. So again, give it some time. So basically, they obtain the number. Okay, can you see that 0.97? Okay, about 0.97, and also 14.03. 0.97 and 14.03. Let's go back. Okay, so basically, you can see 0.97 and 14.03. So I actually has transformed this part, okay, the schematic of this transmission line into microstrip line, having the width of 0.97 and the length as 14.03. Let me give you another example. Okay, let's do this 14.42 ohm, okay, which is here. So from here, you know that the width is actually 4 mm and the length is 13.07. Okay, so the impedance is 14.42. So again, let's switch to the schematic. Okay, so what I need to do is I just enter my impedance, okay, because it's still a quarter wavelength, so I can calculate it. Okay, so give it some time. So done. Can you see that the width is 4 mm? The length is about 13. Okay, so if you switch back to the microstrip line, okay, so you can see here, okay, the width is 4, the length is about 13. So from here, you actually can do a synthesize, just use the particular resource from online. You actually can transform all this so-called transmission line step by step into microstrip line with the W and also the length. So with this, I'd like to end my discussion. Okay, for this particular video, I have shown clearly how can we actually transform from the schematic of the transmission line into a microstrip line. And you can actually make use of online resource rather than the tedious step-by-step calculation. With this, That's it for today's discussion. Please help to like, and once again, sincere thanks for your strong support. I hope to see you guys soon. Thank you.